Since Java 25, Hello World has become much more approachable to beginners. In particular, they are no longer confronted with keywords that simply don't make sense at that stage. But I think that doesn't go far enough. For example, void doesn't really make sense without a type system, and void is a very special type, and main doesn't really make sense if you don't know functions, and main is a very special function. So why don't we start with statements? Why can't we just execute this one line and get Hello World? Or going even further, why isn't Hello World itself something that makes sense and can be evaluated? And then we see the result of Hello World is Hello World of type string. Yeah, so the idea is start with expressions, work your way up to statements, then functions, and then classes. What can we do with expressions? For example, we can see the math that we know from school also works on computers, right? Computers can compute these math formulas, and the result is a whole number. Then we can see that multiplication takes precedence over addition, and if you don't want that, you can use parentheses, just like you would expect. Okay, then if you add very large numbers, the result can overflow into negative numbers. Why is that the case? There is a maximum value of int, and if you add 1 to that, then you get a negative value. So the integers are not even a straight line from minimum to maximum, but they form a circle, if you will. Are there other things that start with m in integer? Yeah, there's also min value. You could also use that directly. Okay, then if you divide 9 by 2, maybe unexpectedly you get 4 because we are still in the int realm. The rest of the division would be 1. But if you want a number like 4.5, you can't use int. You have to use double. Double comes with its own surprises, so 0.1 and 0.2 is not exactly 0.3. Why is that the case? Because computers don't really like dividing by 10 behind the decimal point. You can see 0.1 is almost 0.1, but not quite. But for example, 0.5 is exactly 0.5 because computers love dividing by 2. Okay, so instead of adding $0.1 and $0.2, you're much better off adding 10 cents and 20 cents. Right, then there are mathematical constants like math pi, which are quite useful in math examples. You also have functions. You put in an argument and you get a result. That's a quite useful concept in general. And you can use or formulate arbitrary complex expressions. For example, here for the golden ratio, we would like to compute phi. Okay, so this function takes 1 argument, this function takes 2 arguments. If you're an audio nerd, you can probably guess what I'm trying to compute here. I leave that up as an exercise for you. And then you would use much more of these expressions, of course. Right, there are also functions that take 0 arguments, and every time you call them, they give you a different result. That would be our first contact with side effects. You could use this for tossing coins, for example. So if the number between 0 and 1 is smaller than 0.5, you get true, and in other times you would get false. Right? And if you literally want, let's say, heads or tails, then you can use the conditional operator for that. And that would be our first contact with strings also. Cool. Now, at some point, we want to move on to statements. What can we do with statements? Of course, we want to introduce variables, and then we can use this, for example, to compute the Collatz number sequence, right? That's a very interesting sequence that spans over very many integer numbers if you start with the number 27. Okay, or we could compute Fibonacci numbers, so start with 2 values 0 and 1, and then compute the next 2 neighbors, then the next 2 neighbors, then the next 2 neighbors, and so on. And then you should see the Fibonacci sequence emerging. And this is a point where we'd say, well, it's probably better to have a loop. Maybe we want to execute this 100 times or something, and maybe we want to execute this until x reaches 1. While loops and for loops. That would be quite useful. We can also implement a guessing game just with statements. So let's guess or make a random number, then we guess the number is 50, and then the computer tells us that 50 is too big, so then we would reassign it to, let's say, 25. Execute that, and let's see, that number is still too big. Let's say 12. That's too small, and so on, right? And of course, here you also wouldn't want to manually switch between those lines. That would be a good idea to use loops, and then of course stuff like print line and read line. Then we would go on to functions. So we know functions from math, right? I would start writing functions like in math, so everybody understands line 87, square of x is x squared. Not everybody is familiar with this type notation from math, so we map from the real numbers to the real numbers, and we simply have a different notation for these two lines in programming, which looks like this, and you could then talk about that in detail. Okay, and then we would call this function. The square of 3 is 9, the square of 4 is 16, and you can, of course, combine those results, right? So I think it's very important to understand that return doesn't print to the terminal, but instead it gives us a value, and then we can compute further with the returned value. Many beginners are extremely confused between the difference return versus print line. Right, and it can get arbitrarily complex, of course. And then you would say, dear student, here's a function, here's a math expression that computes the distance from the origin to 3, 4. Why don't you make this a function where you can choose the x and the y coordinate, right? And then you would make lots of more functions until students understand what functions are. Okay, and I think then you can talk about the very special main function, you can talk about the void data type, and so on. So this tool that I wrote uses the JShell API. You may be familiar with the JShell tool itself, but it also has an API which you can call from Java. It's about 300 lines of codes, not counting blank lines, and you can do it in a weekend. So this is not an advertisement of my own little tool here. I would expect that in the last 8 years since the JShell API existed, dozens, if not hundreds of tools like this have been developed by teachers, maybe in private or maybe open source, I don't know. But I think it's worth discussing, should we start with classes and then work our way down, or should we start with expressions and then work our way up? And since I'm very fond of REPLs and functional programming languages like Clojure, of course, I love to start with the expressions and then work myself up.